Guys, here I welcome you to my new channel, Teach for Good. As per the name, it suggests yes, it's something we're doing here to raise fund and spread knowledge as well. So it's quite necessary in this time period of time where lockdown is being continued. We have to raise some fund for the PM fund as well. And while you're watching on your screen, it clearly states that even if the lockdown ceases, every penny profited will go for the charity. So let's see what next. So the thing we're dealing with today is variable mass system in mechanics. I would first like to state that I'm not going to put stress on any of the examination students are dealing with nowadays, JEE or NEET or any of the examination, science-based examination. We're learning it for just learning sake, and it's quite interesting. It will be a great one, trust me. So let's begin. It's variable mass system, variable mass mechanics, and it's quite simple. I'm not going to teach, and I'm just going to teach in some special way. I don't think I would be learning anywhere else from here the techniques, because you don't have to learn so much about center of mass and all and stuff before learning this thing, because I believe it's nothing but Newton's law. So it will be some different way, not like those being taught in the coaching industry or in the whatever JE preparing institute nowadays. It's one of the favorite topics of such high level Olympiads and all. So I'm not going the way they teach. Yes, you can solve their approaches, you can solve their questions, their puzzles, but obviously it's some different. You'll definitely enjoy it. So what you have to learn before learning this thing, you just have to have a basic idea of NLM. Basic idea, and the mathematical grasp of Newton's second law. You don't have to get around thrust, force, or impulse. Not necessary at all. And force analysis is must here. And one thing I left out here is relative velocity. The concept is somewhat important because we are going to deal with something rocket science like thing here further. Just wait and watch, you'll enjoy. So the NLM thing, you have to know about NLM, and then when you say NLM, there are three laws: the first law, the second law, the third law. First law, everyone knows it's basic inertia, that every body, a mass body having a mass can have a property called inertia. So it retains its state of, it wants to retain its state of motion being rest. It's want to be stayed in rest as well, and in motion it always want to be in motion unless and until an external force is applied. So it's the basic first law. Third law, everyone knows that there is force always exists in action reaction pair, which is equal in magnitude and opposite in direction. The second law, as soon as we hear the topic, the second law, we just hear about second law, the thing we get it in our mind is force per hour mass into acceleration. Is this something simple? Yes, it is simple, but I don't think that it's the only thing in the second law. In fact, this is not the second law. This is something, the derived result we get from the Newton statement. So what's the second law? I think the second law is what Newton gave is force is directly proportional to the rate of change of momentum, that is force always act in the direction of the momentum being changed, that is in the per unit time, you can say. So the mathematical statement out here is this, that force is rate of change in momentum, and you know momentum is nothing but mass into velocity vector. See, vector vector, so dimensionally it is correct. Vector vector, dimensionally it is correct. Okay, so you know we can write it like this. It's no harm in this. Force is the rate of change of mass of velocity, mass into velocity vector, and then vector. We'll further write the equations and see that what we are doing in our high school, what we had been doing there, something that is occurring in history. That mass is being a constant term. You just turn mass out from the derivative. Constant का derivative multiplied into variable, the constant term comes out. So it's mass into dv by dt. And dv by dt is nothing but acceleration. So you get force equal to mass into acceleration. But have you ever wondered what if the mass is not a constant term? And I think what you must be wondering, if you're a student of calculus, if you have a basics of calculus, you must have got the hint or got the point I'm wanting to put forward. So what it is. So let's see. We'll get in touch with that also. What we're doing. This is only true when your mass is constant. Yeah. So we'll see what next. But if mass is variable quantity, then also the Newton statement is always true. You cannot change the Newton statement or the second law of mechanics. Obviously, it is true in the classical mechanics, so you cannot change it. This statement is always true. So what next? Okay, so it's nothing, it's calculus. You see, derivative of a term which is a multiple of two variable terms. So d of u into v is du into v plus v into du. You must have been knowing that if you're a basic student of calculus. So let's see what we are doing next here. See, so this is the term. I'm wanting to say that you get this result, and it's an important result. You, this is nothing to be learned to. It's definitely in your mind, and using this we are going to solve the whole variable mass system. We're not going to introduce any difficult stuff or any tough task of calculating thrust, force and all. I don't want to indulge in that which is being taught in the coaching industry and all that I've experienced, and I think most of you must have been experiencing as well. So let's move forward. I would like to have 2 to 3 illustration, not just illustration, three situations we're going to analyze and understand the beauty of the mechanics when we deal with variable masses or just deal with the Newton's law, because we are not learning any specific topic here, the variable mass system. We're learning Newton's law and the beauty of it. So proceeding forward, and putting forward a very good situation you were saying before. It's something we're going to analyze. It's a cart here whose mass is m0. Whatever material it is made of is rigid material. Okay? Of constant force is driving it. Okay, it's always constant and external force. But what's special here is that, see, funnel containing sand, dropping the sand, or you say mass particles having mass at mu kg per second. So dm by dt is being given to you. Dm by dt is nothing but rate of change of mass. It's mu. It's been given here. So you don't have to worry about that. And we are just thinking, so what all gonna happen here? We'll just see. Okay. So let's see what is all going to happen here. Here the mass is being increased with time. We are observing our system as this cart, and whatever particle which has entered it, which is being entering, and the present, future and past as well. Okay, so let's see. Actually the mass is increasing, so momentum increasing. If the momentum is increasing, then force must be there. Force is there, momentum increasing. Newton said, then obviously velocity is changing. Okay, so what is all going to happen? The force is there, velocity is also variable, we concluded it. The force is something here. Okay, we don't have to worry about it, we'll calculate. So we'll write the Newton's law that we have been stating it beforehand. We'll just write it down. Okay, see what we are doing. Force is nothing but mass into dv by dt plus v into dm by dt. Mass is scalar quantity. See, again I will prove it dimensionally. Vector, scalar into vector is vector, vector into dm by dt is scalar, so vector, so it's vector quantity. Let's move forward. How would I write mass? Then I'm going to elaborate it. We'll just work upon this equation and derive whatever we can. Okay, so let's see what we can do. Mass, see, mass, we are, and I've already stated that we are, our system to be observed is this cart. So mass of this cart is our system, our body to be considered, and we are not concerned about how much sand extra is going to occupy the position on the cart or just increase the mass of the cart. So we're just considering the mass here as the mass of the cart at the time instant, at the time instant t. So we are not concerned future and past. Now when you're concerning about छोटा time dt, where छोटा time dt में जो हो रहा है, that we are concerned with, we are worried about. We're not worried about further or beforehand that. And obviously the dt time just after time t. So this is the consider. In physics we always do the same thing. We choose an instant and a relative change of the instant. So we not just look for, we'll proceed on what we are going to do now. We'll write the mass. What is the mass at time instant t? We'll just look forward to write down the mass at time instant t. Okay, let's see what we can write. I've written it already. I'm explaining you what is the mass at time instant t. See, this is the mass at time instant t, that is m naught plus mu t. Initially it was m naught. Okay, then what happened? At mu kg per second the sand starts falling. So at time t, you see time t में कितना आएगा, so rate of change into the time t, so you get the mu t term. So this is the mass at time instant equal to t. You don't have to worry about that. So dv by dt, this one, this is carried down, there's no harm in that. And that v into dm by dt, we already knew it's mu, and v is the velocity vector. So you just go and solve it and you just get the thing on differential equation, which you have to solve it to get what calculus, apply calculus here, and we'll definitely enjoy it. But here we are putting the limits out here, how we can put the limit out here. So I'm just going to teach you putting limit out here. See, initially we are considered time is relative, so the time we are considering from is time barabar 0 second, and at that time the body was at rest. It's being given in the situation, or I am stating it that initially the body was at rest. If it would have not been given, then things would have changed, some different story. But I am telling you that at initially when no zero time mein, the body, the cart or the body that we are observing is at rest, and at time t, what happened? Velocity of the body becomes v, that we are going to just see what is the velocity, variable velocity. We are going to find the variable velocity and nothing else. So we are see, so we solve this calculus, this differential equation, and I have solved it for you, and we get the, see, we put the limit here and we get the result. It's very simple, we get it. So you can see the result. As but the time increases, the velocity is increasing. My god, the velocity is increasing, you see. So that the we cannot just say just watching it. We have to be mathematical, or somewhat calculus must be in our domain minimum. Okay, so you have seen this, that we have learned a similar case. Now I'm going to bring forward another situation. Let's see what it is. So you're watching out. Yes, it's somewhat rocket science. Congrats, you are going to learn, and it's very interesting. See, a rocket, initially it was moving with a u velocity vector in upward direction at time equal to 0, and the mass of the rocket was m naught. But maybe due to change its velocity or direction, the exhaust was put on. So exhaust was put on with the velocity v r, small r, matlab v naught like v r. So the exhaust, what is exhaust velocity? Actually, this astronaut, so the scientist, or maybe you call it the pilot, have put the button, exhaust button on, and is watching the exhaust as VR. He is watching that the exhaust coming out of the propeller is at a velocity VR. So what is VR? VR is nothing but the relative velocity. That is the velocity of the gaseous particles or whatever coming fuel burning out from the propeller is coming out with a velocity vr in opposite with respect to the rocket, obviously in the downward direction, uh, the propeller from here. Okay, so it's given that at time t naught pe velocity becomes v, mass is m, this instantaneous mass, and v, velocity is v, that I have told you from the diagram. So let's analyze it further, what's all going on. So I've divided my thing into two portions, so we have an ample space. So I've just explained to you that velocity of exhaust with respect to ground. We are going to calculate that. You'll soon come to know why I'm going to calculate that, or why I'm putting stress on that. Something to learn special. So let's see what we can do. So I've told you already that velocity of matlab engine, or with respect to rocket exhaust, sorry, velocity of exhaust with respect to rocket is VR. Okay, no harm in that. So what's next? So as I would like to revise something, or just tell you something, that velocity of A with respect to B, you must be knowing that velocity of A minus velocity of B, vector, everything is vector, 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 vector. You must be knowing this. I just want to recall things. Okay, so let's see. So here I'm done nothing but just whatever I told you physics before. I just putting this and this. See here the velocity, again see here the VR is your vector, VR वेक्टर है. तो हम वहाँ से डायरेक्ट मैग्नीट्यूड लिखना चाहते हैं. हम ऊपर वाले डायरेक्शन को पॉजिटिव कंसीडर करते हैं, नीचे वाले डायरेक्शन को नेगेटिव कंसीडर करते हैं. साइन कन्वेंशन अब उल्टा भी कर सकते हैं, कोई फ़र्क नहीं पड़ता है, बट आपको पूरा साइन कन्वेंशन ही चेंज करना होगा. सो यू सी हियर दैट what I'm doing, I'm putting it minus VR. VR is the magnitude, already been stated the situation. I would not call it a question, it's a situation. So it's minus of VR. So what we obtained here, the velocity of exhaust with respect to the ground frame, and why we need it you'll further come to know. So we see here that I have made something with very concluding all here. Let's see what we are going to, but I am meaning to discuss here. This is nothing but I'm analyzing. I'm going to calculate what force is being exerted on the rocket. So let me first make it clear that we are analyzing the exhaust, the gaseous particle or a small chota sa particle that we are going to consider in our observation. So what we are going to go, let's see what. First of all, I've already said that the chota particle was first moving in the upward direction. Okay, that is with the speed of rocket. So earlier it was moving with the rocket velocity, but then some force acts, which some people call it a thrust force and all. I'm not going to indulge in such stuffs, but you see later on it starts moving with the velocity with respect to ground. So there is a change in velocity, which is nothing but this is the uh, this is the change in velocity, and into multiply, so this is change in momentum. So what is all going on per unit time? Rate of change of momentum. So this is the force. So simple. Some people name it as thrust force, and just name it as the relative velocity. You see, relative velocity I've already explained. Exhaust velocity is relative velocity into the dm by dt. So it makes the thrust force. And some people name it or learn straightforward learn the formula thrust force. But I don't think it is necessary or at all needed at this stage, because we are learning aspects and all. So we'll move forward and see what later we can do. So now what we are going to do is analyzing the equation of force of this rocket. How come this rocket going to be analyzed? Let's see. It'll be good and maja aayega. Let's see. So I'm writing the net force equation, that is mass into acceleration, and you know that mass into acceleration is nothing but dv by dt. So no fault in that. Okay, so c mass into acceleration. Now as per I said, the exhaust, ये जो exhaust का particle था, I'm moving back to my previous slide because I want to explain something. See, the exhaust particle पे force नीचे लग रहा था, क्योंकि पहले उसका मोमेंटम रॉकेट का स्पीड था, बाद में वो नीचे की तरफ आने लगा. तो जो भी फोर्स लगा होगा वो नीचे के डायरेक्शन में ही लगा होगा. That is why rocket, on rocket the force must be acting in upward direction. Okay, रॉकेट पे अपवर्ड डायरेक्शन में और छोटा पार्टिकल पे फोर्स नीचे डायरेक्शन में। सो एक इंटरनल फोर्स लग रहा है, मोमेंटम कंजर्व्ड होगा। ये इसका डिस्कशन नहीं करेंगे क्योंकि ग्रेविटेशनल फोर्स खैर उसका ज़रूरत भी नहीं है, बिल्कुल कंजर्व होगा। ओके, बिकॉज इंटरनल फोर्स नेट फोर्स जीरो। थर्ड लॉ से दोनों फोर्स इक्वल होगा, इसमें कोई डाउट नहीं है। ये दोनों फोर्स, ये वाला फोर्स और ये वाला फोर्स इक्वल होगा, ठीक है। सो व्हाट वी हैव डन हियर, हम लोग वी हैव कैलकुलेटेड द फोर्स अप्लाइड ऑन द एग्जॉस्ट एंड थर्ड लॉ से थर्ड लॉ से वी हैव प्रूव्ड that the proof kya, we know that the forces are same in magnitude, so this force is applied on the rocket in upward direction. So while analyzing the force equation of a rocket, we'll do something. See, ये फोर्स था, इस पे ऊपर की तरफ फोर्स लग रहा है जो हम कैलकुलेट कर चुके हैं पिछले स्लॉट पे. सो विल मूव फॉरवर्ड टू राइट द फोर्स एंड यस वी हैव रिटन द फोर्स. सी relative velocity into dm by dt, which you don't have to learn, हमको याद है because I have been taught in the coaching industry, but I don't think it is necessary, and yes it is not necessary. So and mg तो नीचे लगते ही रहेगा, इसका जो वेट होगा, मास, इंस्टेंटेनियस मास का mg. सो लेट्स सी mg नीचे की तरफ, अगेन ऊपर वाला सारा डायरेक्शन हम पॉजिटिव लेते हैं इसीलिए ये पॉजिटिव है, और नीचे वाला सारा डायरेक्शन हम नेगेटिव लेते हैं इसीलिए ये नेगेटिव है. नेट एक्सेलरेशन जो बॉडी का है वो ऊपर की तरफ है तो पॉजिटिव है. इट्स वेरी सिंपल. नाउ लेट डू. अब क्या किया हम, व्हाट वी आर डूइंग, उसी को मतलब जगल अप, वी जगल्ड इट अप एंड अगेन फॉर्म द डिफरेंशियल इक्वेशन. Solve it. Now putting the limit, I would like to discuss it, but I would not lay more stress on it because in the previous illustration I have told it and it was very clear about, I was very clear, I think so. So now writing the limits and all, and one other thing I have done here, I put this minus because you know the dm by dt, this term is negative, so I don't want the things to be messy. I'll put here m say m naught, actually it's m naught m, so this term will be negative, so we just put here negative. We don't have to worry about that. Okay, we don't have to worry about that because dm by dt is negative, so we put there negative. And if you are really worried about it, then यहाँ से भी आप डायरेक्ट निकाल सकते हैं, बहुत ज़्यादा टेंशन लेने की ज़रूरत नहीं है. इट्स क्वाइट ईजी. So let's move forward. Now we have put the limit. How come we have put the limit? पहले u naught था velocity, बाद में भी हो गया. जब u naught velocity था तो mass m naught था, and when mass was m naught we started observing the thing that the time is equal to 0, time is equal to t तक we have been seeing. अभी washed it out and the mass was m, that was the instantaneous mass क्योंकि हम t time में consider करते हैं. And now we solve this all and we get this result. So simple. So yes, congrats, you have learned rocket science. Thoda rocket science we have learned it, and yes, it would be nothing different. We'd be just considering few other things into we'll consider it in our accurate analysis and mathematical, and it would definitely be the basics. Yes, it is rocket science. Congrats. Now here another aspect, and it's a very cool one. See, what I would like to describe the situation, another illustration of the situation, which will help us to think more about the variable mass things. So there is the chain which is dropped in a straight this manner. The chain is falling this way. That is, the chain is not getting heaped. It does not heap. I will tell you later on why we are talking about this thing. But yes, it's very interesting. Something behind that statement, some concept is also lying behind it. So we're seeing this, that this chain is falling down. How we are going to see what we can find out, what we can do. So let's see. I've drawn an I want to analyze thing. I don't want to mess the situation of the question or whatever you say in the diagram, so I made another diagram out here. So, and one another data I would like to tell you, which that this part is L by 2. Okay, this part is half the length which is being drawn. जब ये गिरना शुरू हुआ था, then it comes up to L by 2 and we are considering things at L by 2 and the whole length is L. Okay, so let's see. Now I am considering, or I am observing as the system, my chota sa part dm, the portion of the chain which is just going to land on the surface, okay, which is just going to stop moving. Okay, so what all we can conclude, let's see. Okay, so I made this. Now I would like to write down the velocity of the following thing. Now you would know the importance of why I said that it is not getting heat. You see that the chain is coming down, it must be having some velocity here, and now it is at rest. So there must be something that the पहले जो momentum था, the momentum was in the downward direction. Now it ceases to zero. What does it means? I'm talking about the dm mass. It means that there is some force which is changing the momentum from downward direction to zero. So what? Force ka direction must be in upward. Must be upward. Okay, that is what we want to calculate. Not want to, if we can calculate, we'll calculate. Let's see what we can do. So I've written down something, the velocity, which is, it is coming down. The force exerted by ground is exerted only the portion which is at rest, because it is not forming heap. If it would have formed heap around here after falling, the force must be exerted in upward direction. ठीक है, upward direction में force लगता, and this thing, the acceleration of this thing which is being falling, जो गिरना, that is more to fall, would not be following with acceleration g. That is why I made the simple situation. We can do it as that situation as well, we can solve that also, but it is a quite difficult task but not impossible one. I would, if you want, you can write in the comment section. I would just if you want, I can make another video, a short video on it later on, a small 5-minute video. If you want, I can make it, but I don't want to deal with that in here. So we just wrote the root 2gl. We know that v square minus u square equal to 2as. This equation we have used one kinematics ka basic equation, and we have wrote this portion. Acceleration is g 2 root under and l by 2, because it has already fallen l by 2. So this is the velocity. Okay, now again we are applying the third law, that is force on chain by table is negative of force on table by the chain. So what we can calculate is the force by table on the chain. We can calculate this term because we can analyze the system, and we are already analyzing at chota dm mass. So let's move for proceed, and we'll definitely calculate it. It is very interesting. Let's see. So same thing what I evaluated, and rate of change of momentum, the Newton statement, and no nothing thrust force and all, no need to indulge in that. See, earlier the velocity of v, which was downward, finally zero, final minus initial change in velocity. ठीक है, change in velocity delta v into dm, because dm mass is not changing, we are analyzing dm mass here. So this is the change in momentum divided by dt. This is rate of change in momentum, which is force. Congrats, we have calculated the force exerted by table on the chain. Okay, so see, I made it much. And one thing I've left out, sorry, the mass, this mass is still falling, so it doesn't have to do with the weight. It is not exerting any weight on the ground. Okay, so this mass which is at rest is also exerting its weight on the ground, which is mg by 2. So this must to have, this is to be considered here, weight. So net force by table on the chain, this is the thing. With it is at rest, it is exerting mg by 2. रेस्ट पे है तो इसके ऊपर भी लगेगा फोर्स, तो उतना ही होना चाहिए, सेम मैग्नीट्यूड में होना चाहिए, that is mg by 2. Sorry for the messy things up here, I cannot write with my fingers. So it's quite messy, but see, we have learned the concept. Now let's move forward. So we've solved it, got this. Further solving it, this, and we have calculated something, not just something, much better things. So see, what you are observing here, a body of just a mass m is exerting more than its weight just because it's falling. It's amazing. That's the beauty of mechanics. You can discover several more things. So this is the last part, the last slot of this term. So I would like to tell you that this channel belongs to charity, and yes, it will work for charity only if you would help us. And if you want any of the help in the any of the topics in the physics or in other subject, I would recommend it to my friends. They can teach it. And in physics, especially in mechanics, if you want any of the help or any of the interesting thing, not I'm not focusing on any of the JE exams or not. If you want to learn the concept, I would try to illustrate it very beautifully if you will want me to do, if I'm able to do so. I think I'm very good at mechanics. I should not uh, tell this, but I think so. So I can help you all out if you really want the help from me. So friends, goodbye. Please don't forget to like, subscribe my channel. Hashtag teach for good.